Now come to the next point, magnetization and intensity of magnetization. Intensity of magnetization. Normally we are representing this with a symbol I. Magnetization or intensity of magnetization. So when any magnetic material, suppose this is, if we are talking about any magnetic material, so in this magnetic materials, atom having certain dipole moment. So but at normal condition, their dipole moment is your randomly oriented like that. There is no proper direction of dipole moment of all atoms, and this is because of the thermal motion of atoms. So first we can say in the substances, atoms are randomly moving due to thermal agitation, so their dipole moment is, randomly oriented as shown in diagram number 1. Let this we can say diagram number 1. So randomly oriented. So net dipole moment of whole substance. So net dipole moment of whole substances or whole substance is 0. So since it is a vector quantity and these dipole moments are randomly oriented, so net dipole moment of whole system is your 0. Now if the substance is kept in a substance or matter kept in external magnetic field, like this. See, suppose this is same substance here, and here we are applying external magnetic field in the rightward direction. So due to effect of, this is let figure number 2, due to effect of external field, the magnetic moment, dipole moment of atoms will try to align in the direction of magnetic field. So due to effect of external field, the magnetic moment of atom, will try to align in the direction of magnetic field. So they can align partially in the direction of field. So they can they can align partially in the direction of field. In the direction of field. Now, if field is increases continuously, if field increases continuously, field increases continuously, the alignment become more and more stronger. Then alignment become more and more stronger, more and more stronger, more and more stronger. When all the atoms is aligned, when the alignment is complete, or when alignment is complete, then it is called saturated state. Then it is called saturated state. Saturated state, and this process is known as magnetization. So, this process is known as magnetization. Magnetization. So, what I said here, the same matter, same substance, now it is kept in external magnetic field. So, due to effect of this external magnetic field, magnetic moment of the atom will try to align in the direction of magnetic field because of the torque. So, as we are increasing the field, alignment gradually increases. One stage will come when the all atoms will align themselves completely, then it is called your saturation state. And so, now that phenomena is called your, or this process is called your magnetization. So, in the magnetization case, we can say the alignment is your almost this your partially, and why it is partially? Because of the thermal motion of the atoms. The atom also having certain thermal motion, and that thermal motion give their random velocity. So, it is very difficult to get all atom aligned exactly parallel to magnetic field. So, this is the alignment finally we can have after applying a magnetic field. So, now how we are defining intensity of magnetization? So, intensity of magnetization means if we are considering any small volume in the material. Suppose I took a small volume V, let this the volume V in the material. So, what is the net magnetic moment of this volume, or net magnetic moment of all atoms in this volume per unit volume? That is called intensity of magnetization. So, intensity of magnetization, so intensity of magnetization I is equal to the magnetic moment per unit volume. It is defined as the magnetic moment per unit volume. So, it means if we are selecting any volume V and the atoms in this volume V have net magnetic moment M. So, that can be said here capital M by V. So, capital M is the magnetic moment of all those atoms which are in a volume V. So, capital M is the net magnetic moment of all atoms which are in the volume V. M is the net magnetic moment of all atoms in volume V. So, in this manner we can define intensity of magnetization. So, just see one of the example, from that we can get better idea how to calculate the intensity of magnetization. See, so as intensity of magnetization is defined as intensity of magnetization I is equal to your M by V. So, the unit of M is ampere per meter square. So, unit of intensity of magnetization is ampere per meter. Now, see, just see one of the example. Let intensity of magnetization of a bar magnet. Let intensity of magnetization of bar magnet. So, let this is a bar magnet, and the pole strength of the bar magnet your M and minus M, the length of this bar magnet your A, and A is the cross sectional area. So, it is given a bar magnet of pole strength M, bar magnet of pole strength L M, and length of magnet is L, and length of magnet is L. So, magnetic moment of bar magnet. So, magnetic moment of bar magnet, capital M is written as M into L. Now, if A is the cross sectional area of bar magnet, then intensity of magnetization, I is equal to your M by V. So, M into L, volume your area of cross section your A, L is the length, L and L cancel, so this become your M by A. So, which can be said? So, unit of intensity can be written as pole strength per unit area. So, intensity of magnetization of bar magnet is pole strength per unit area or pole strength per unit area, like we can write intensity of magnetization of bar magnet. Now similarly, if we want to calculate the intensity of magnetization of solenoid, see. Now see another example, intensity of magnetization of magnetization for solenoid. See here, as let this is your solenoid, and in this solenoid, suppose I naught is the current. So because of the current I naught, magnetic field inside the solenoid is given as B naught is equal to your mu naught N into I naught. This is the magnetic field inside the solenoid. Now, if a magnetic material or a rod of magnetic material here kept inside this, suppose a rod of magnetic material or rod has been kept inside the solenoid, due to effect of magnetic field produced by the solenoid, the atoms of the rod get ionized and these atoms get magnetized. So if I am looking the cross sectional view of the rod, see, let this is the rod which has been kept here. So in this rod, each atoms like this, each atoms act just like a current carrying solenoid or current carrying loop. See here, if we are looking the two adjacent atom like this, so in these two atoms electrons are orbiting in the same direction. Here I took your anti-clockwise, here anti-clockwise. So what is observed, since atoms are very close to each other, so see the here, in one of the atom current here like that, another atom current here upward, so resultant current we can say 0. What we will have, if I am talking about the outer atom which is on the surface, so here in this atom current here like that, here your current is in this manner. So outer surface, if I am talking about, it appears the current is in this direction, so that current is called your induced current. So this IM, that is called your induced current here. So due to this induced current, magnetic moment due to we can say magnetized current, M is equal to your, for one of the loop, let one loop have cross sectional area your A, so IM into A. Likewise, number of loops are let total N. So total magnetic moment is this, and if L is the length of whole rod, so magnetization or intensity of magnetization, so intensity of magnetization I is given as m by v, m magnetic moment by volume. The magnetic moment will be here I m into A into N by volume A into L. So, A and A cancel and N by L will be your small n. So, this we can say small n into I m. So, here I is the intensity of magnetization, while I m is the magnetized current and n is the number of turns per unit length, where n is a number of turns per unit length, while I m is the magnetized current. Magnetized current. So, this is the way by which we can calculate intensity of magnetization in case of solenoid. Now, come to the another term, another point.